I would like to introduce a new chapter, that is the carbonyl compounds. Carbonyl compounds are nothing but aldehydes as well as ketones. So, before starting the preparation as well as the chemistry of these carbonyl compounds, I would like to introduce our daily used some compounds which are related to the organic material. The first one is the compound that is a citral, which is isolated from the lemongrass, and normally we are using into so many medicines. And the second compound is cinnamaldehyde, that is isolated from the cinnamon sticks, which we are using everyday masala. And the next one is that is 2-heptanone. It is also known as blue cheese. Usually we are using into the pastas as well as the pizzas. And the most important as well as the healthy compound is the benzaldehyde, that is isolated from the almonds. These are the dry fruits which normally we are using for the health purpose. And next we will start with our lecture plan for this, especially the aldehydes as well as ketones. That is, the first one is the preparation methods of aldehydes, and the second one is the preparation methods of ketones. So, now first we start with the synthesis of aldehydes. These are the general methods to synthesize aldehydes. First method is by oxidation of primary alcohols by using PCC. PCC is nothing but pyridinium chlorochromate. And the second method is by reduction of esters and acid chlorides. Esters as well as acid chlorides are the derivatives of the carboxylic acids. These esters and acid chlorides on treatment with DIBAL-H, that is diisobutyl aluminum hydride, followed by the protonation, and the second one is acid chloride, that is treatment with lithium tritertiary butoxy aluminum hydride, followed by the water to get the aldehydes. And the third one as well as the most important method is hydroboration as well as oxidation. And the next we will move on to the synthesis of ketones. These are also the general methods to prepare the ketones. First one is by oxidation of secondary alcohols with chromium reagents. Second one is by reaction of acid chlorides with alkyl cuprates, and the third one is the Friedel-Crafts acylation, and the fourth one is hydration of alkynes. First we will start with the preparation of aldehydes. That is, the first preparation is oxidation of alcohols. Oxidation occurs by replacing the carbon hydrogen bonds on the carbon bearing the OH group by CO bonds. So, here it is the oxidation means the addition of oxygen or the removal of hydrogen, or we can also say that the increasing in the number of carbon oxygen bonds or decreasing in the number of carbon hydrogen bond. That means the oxidation mainly depends upon the nature of alcohols we are using as well as the nature of reagents we are using over here, whether it is a primary alcohol or secondary alcohol or tertiary alcohols, or we can say that what type of oxidizing reagents we are using. And these are the sum of the selective as well as the non-selective oxidizing agents. The first one is the chromium oxide, and the second one is the pyridinium chlorochromate, and the third one is the potassium permanganate. And the remaining also I have given these examples: osmium tetroxide, silver oxide, hydrogen peroxide, and peroxyestic acids. That means oxidizing agents basically classified into two categories, that is the reagents which contains oxygen-oxygen bond, and the reagents contains oxygen as well as the metal bonds. So, chromium, potassium permanganate will comes under the oxygen metal bond, or pyridinium chlorochromate is also comes under the metal oxygen bond, whereas this H2O2, that is a hydrogen peroxide, and peroxyestic acids comes under the category of oxygen oxygen bonds. Here we are using that selective as well as non-selective oxidizing agents. It means that some oxidizing agents will use only up to the aldehyde stage from alcohols, and some other oxidizing agents are using for the extension to the aldehydes, that is up to the carboxylic acids. And basically these are the main important characteristic features of the oxidation, that is when an alcohol is oxidizes, hydrogen is lost in the form of water and the carbon forms a double bond to the oxygen atom. Oxidation occurs when carbon loses electrons by forming bonds to oxygen and loss of a hydrogen. And the third one is the product formed depends upon the number of hydrogens the alcohol contain. So, now we will take the example of the general reaction, that is the primary alcohols. In starting there is only one carbon oxygen bond, which on oxidation gives rise to aldehydes, which contain two carbon oxygen bonds, which on further oxidation gives rise to carboxylic acid, which contains three carbon oxygen bonds. And now we will see the basic mechanism of the oxidation of primary alcohols. Here I want to show you the example of chromium oxide. So, here the primary alcohol, the lone pair of electrons on oxygen atom, which acts as a nucleophile, attacks on the electrophilic chromium atom in the first step with the formation of the protonated chromium complex, which on further loses a proton, gives rise to a chromate ester. This chromate ester finally loses a proton here, and then with the formation of aldehyde. So, these are the steps, that is the nucleophilic attack of the alcohol on the electrophilic metal, that is the chromium, and the second one is the formation of the chromate ester by transfer of a proton, and the third one is base, either it is water or it is a starting alcohol acts as a base which removes a proton. And one more thing here I want to emphasize is primary alcohols oxidize to aldehydes under mild conditions using pyridinium chlorochromate in the presence of methylene chloride. So, this is the example reaction of the oxidation of primary alcohols with pyridinium chlorochromate, and the second one is with the potassium dichromate, that is the primary alcohols oxidize to carboxylic acid under harsher reaction conditions with sodium dichromate or potassium dichromate or chromium oxide in the presence of water as well as the sulfuric acid. And this is the mechanism, that is the oxidation of primary alcohols to aldehydes, that is whatever we have seen in the previous slides, those are the three steps includes, gives rise to aldehyde. And further oxidation, that is the addition of water to form a hydrate. This is most important step to understand the mechanism of oxidation, because if you want to stop the reaction up to the aldehyde stage, we required milder oxidizing agents, that is pyridinium chlorochromate in methylene chloride, or if you want to continue up to the carboxylic acid stage, we can use the remaining potassium dichromate or potassium permanganate or sodium dichromate, and here the oxidation of hydrate to the carboxylic acid in the last step. Okay, secondary alcohols on oxidation gives ketones, which on further oxidation gives acids. And tertiary alcohols, even though it does not contain any alpha hydrogens, it undergoes oxidation with acidic oxidizing agents, gives ketones. Here the oxidizing agents which are in the presence of acid, first it will converts the tertiary alcohols into alkenes, which on further oxidation gives rise to epoxides, which on further oxidation gives rise to ketones. And the next method to synthesize the carbonyl compounds are the oxidative cleavage. So, this is the method of the oxidative cleavage, that is the ozonolysis, that is the addition of ozone. So, aldehydes and ketones are obtained by oxidative cleavage of alkenes by using ozone. These are the two resonating structures of the ozone. The first step would be the formation of ozonide, that is the lone pair of electrons on ozone which interacts with the electrophilic carbon atom with the formation of molozonide, which on further rearranges to form the aldehyde as well as an intermediate. These two further reacts together to give a ozonide, which on reduction gives rise to two molecules of the carbonyl compounds. So, here in this case one is the aldehyde, the other one is the ketone. So, depends upon the starting reagent, starting alkenes what we have chosen, the products will be formed. The next method is the reduction. So, here I would like to explain the reducing process. There are three ways to add hydrogen. All reducing agents provide the equivalent of two hydrogen atoms differing in how hydrogen is added. This is the first way of addition of hydrogen, that is the addition of molecular hydrogen. It occurs in the presence of metal catalyst that acts as surface on which the reaction occurs. Here in this case, the example we can say that is a hydrogen in the presence of nickel catalyst or hydrogen in the presence of palladium catalyst. And the second way of addition of hydrogen is the 2 protons and 2 electrons to the substrate. Here in this, normally we will use the alkali metals as a source of electrons and liquid ammonia as a source of protons, that is sodium in liquid ammonia. And the third way to add hydrogen is the addition of hydride, that is the examples are sodium borohydride or lithium aluminum hydride. These reagents gives hydrogen that is as a hydride to the substrate, then the proton is added from the water or alcohol. So, here the metal hydride reagents contain polar metal hydrogen bond. So, because metals are electropositive and hydrogen attached to the metal is comparatively electronegative, which creates a dipole moment. So, in the mechanism, the first step is the lone pair of electrons on hydrogen as hydride, which interacts with the electrophilic carbon atom with the polarization of the electrons towards oxygen. In the first step, hybridization of this component is sp2, which converts into sp3 hybridization as an intermediate. So, after that the protonation gives rise to the aldehyde, which with the removal of the leaving group. So, here the second way, if we want to continue with this reduction process further, it reduces to the alcohols. And the next one is a reduction of nitriles and acid chlorides. These nitriles which on reduction with the Dibal H, that is diisobutyl aluminum hydride, followed by the protonation gives rise to aldehyde, and the nitriles which are also reduced by the tin chloride or stannous chloride in the presence of HCl and followed by the protonation gives rise to aldehyde. And the third one is the acyl chlorides or acid chlorides on reduction in the presence of palladium as well as the barium sulphate gives rise to aldehydes. So, here this reagent, that is the reducing agent palladium as well as barium sulphate, if we will use, then we can say that this is a Rosenmund's reduction. And the next synthesis is the hydroboration oxidation process. So, name itself indicates that the addition of borane forms an organoborane, and the second step is oxidation with basic hydrogen peroxide forms an alcohol, and the tautomerization of enol forms a carbonyl compound. The overall result is the addition of water to a triple bond. This is a general reaction of hydroboration and oxidation. There is a two-step reaction that converts an alkyne to a carbonyl compounds. The first step involves the addition of borane to form the boron complex, which on further oxidation gives rise to enol, which on tautomerizes to gives rise to ketone. So, here the first step would be the, if it is an internal alkyne, it gives rise to ketone. If it is an terminal alkyne, gives rise to aldehyde. And the next preparation is ketones from acid chlorides. Acid chlorides on reaction with Grignard reagent, that is RMGX, followed by the protonation gives rise to ketone. And the next one is the from the acyl chloride, which on treatment with dialkyl lithium cuprate followed by the water addition of water gives rise to ketones. And the next most important as well as the interesting synthesis of ketones is Friedel-Crafts acylation. Normally Friedel-Crafts acylation will be used to synthesize the aromatic carbonyl compounds. So, here it is the benzene reacts with the acyl chloride in the presence of a Lewis acid, that is aluminum chloride, gives rise to acetophenone. So, here the acyl group which transfers from one component to the other component. The Friedel-Crafts reaction involves 3 steps. The first step would be the generation of the electrophile. Here the electrophile is acylium cation. The acylium cation can be generated from the acyl chloride or acetic anhydride by using a Lewis acid, that is aluminum chloride. And in the second step, addition of the electrophile to the benzene ring, this electrophile, this acylium cation, which interacts with the benzene ring, which is a nucleophile, gives rise a resonance stabilized sigma complex. And in the third step, formation of the product, this aluminum chloride removes a proton on the carbon bearing the new substituent, thus reforming the aromatic ring. And the next synthesis process is from Grignard reagent. These are the some compounds, important compounds, which reacts with Grignard reagent to give carbonyl compound. The first one is the alkyl cyanide, and if we will use the alkyl cyanide, you will get this ketone is a product. If we will use the hydrogen cyanide, it interacts with the Grignard reagent followed by the acid hydrolysis, gives rise to aldehydes, and the remaining acid derivatives are also there, esters, anhydrides and amides, which also reacts with the Grignard reagent followed by the protonation, gives rise to ketones, and formamide and then formic ester, which are also interacts with the Grignard reagent to give the aldehyde. This is the important method of preparation of ketones, that is the hydration, addition of water to the alkyne. So, here one thing is important, if it is an internal alkyne, there is no need to add the mercuric sulphate, which acts as a catalyst. If it is a terminal alkyne, which is less reactive comparative to the internal alkyne, requires a catalyst for the addition of water. So, in the first step, addition of water. So, here it is a terminal alkyne. So, that is why we have used this one mercuric sulphate in the presence of sulfuric acid, which forms an enol compound, which further tautomerizes to give the ketones. So, the mechanism involves, the first step involves the addition of the mercuric ion with the formation of mercuric complex, which is highly unstable. Now, the addition of water takes place followed by the protonated mercuric complex, which loses a proton, gives rise to enol, mercuric enol complex, and this mercuric enol complex further tautomerizes, gives rise to keto-mercuric complex, which loses a mercuric ion, gives rise to ketone. So, general steps involved in this hydration is addition of water is known as hydration. In the presence of strong acid or mercuric catalyst, the elements of water add to the triple bond according to the Markovnikov's rule. The initial product is an enol, which tautomerizes to ketone. And now, this is the summary of the preparation of carbonyl compounds. So, carbonyl compounds, that is aldehydes and ketones, can be prepared by oxidation and reduction of alcohols. Aldehydes and ketones can also be prepared from Grignard reagents, and only aldehydes can be prepared by hydroboration oxidation of alkynes, and only ketones can be prepared by Friedel-Crafts reaction as well as hydration. In the next session, we will see the reactivity of aldehydes as well as ketones, how they will vary from each other, even though the carbonyl compounds as well as the carboxylic acid derivatives contains the same acyl group, but the important reaction or the characteristic reactions of aldehydes as well as ketones are the addition elimination reactions, whereas in the case of carboxylic acids as well as their derivatives are having the substitution reactions.